Hello students, so let's start with the section B of paper of 2025 May. That's question number 14 that says this question is about nitrogen, hydrogen and the compound. Ammonia is produced in the Haber process. Nitrogen and hydrogen react at a pressure of 200 atmospheres and a temperature of 725 kilo. So whenever you're solving a question, try to underline the value so that later on you don't need to search them again and again using an iron catalyst. Explain how catalyst increases the rate of reaction using Maxwell-Boltzmann distribution shown. So actually the curve is shown to you and according to the collision theory. So they're asking what will be the role of catalyst. Everyone know that a catalyst always decreases the energy of activation by providing an alternate pathway. More particles will have energy greater than the energy of activation. So the energy of the particle will be more than the energy of activation, and the number of obviously the successful collision increases. So for as it is of 3 marks, so you have to give at least 3 points to gain full credit here. Then we have part B of the same question. Storing and transporting hydrogen can be difficult due to its low energy density. This has led to a use of various hydrides which contain a high proportion of hydrogen and are easier to liquefy and transport. Explain the difference in boiling temperature of group 5 hydrides and detailed description of intermolecular forces are not required. That means you don't need to mention the intermolecular forces. So here what you're going to say, as you're going down the group, hydrides, obviously hydrides have got London forces, so this is going to be your point 1. And then as you go down the group, as we are going down the group from nitrogen, phosphorus, acetylene, and here what is happening, as we go down the group, the number of electron increases, hence London forces become stronger, because as you go down the group the proton number also increases, hence electron number is also increasing, and that is causing the London forces become stronger. Only ammonia has a hydrogen bond. Only we're talking about ammonia here. Rest of them we're going to consider it as having a London forces. So hydrogen bonding is stronger than London forces. Again, because it's of 4 marks, so you have to give 4 valid points here. Hydrogen has been proposed as an alternative fuel to petrol. So we're talking about the alternative fuel. Explain why hydrogen is more environmentally friendly than alkane. So you have to give a comparison between these two, why hydrogen is used instead of alkane. So here obviously 3 marks, so you have to give 3 points. Hydrogen burned to produce water, which is not harmful to the environment. And then you have to compare it when alkanes burn, carbon dioxide is produced, and carbon dioxide is a greenhouse gas and that contribute to global warming. So basically you have given 3 points. This was an easy question. Then we have ethylamine may be prepared from the reaction between ammonia and bromoethane. State the condition for this reaction. Obviously these are the there are many reactions that you need to learn the conditions and how they're going to be performed. So here we know that whenever you are talking about amines and their reaction with ammonia and bromoethane, it means alkane hydrides. In that case, bromoethane, alkyl halide, or you can say halogenoalkane, right? So bromoethane is a halogenoalkane. So here what is going to form, obviously it's going to be done during alcoholic solvent, or you can use a word ethanolic solvent, and then obviously a seal tube because of the ammonia gas produced. Complete the mechanism for the reaction, include curly arrow and relevant dipoles and lone pairs. So here what actually is happening, the reaction is between ammonia and it's between bromoethane. So we have halogenoalkane and ethylamine. So alkyl amine group, this is ethylamine and halogenoalkane. So this is halogenoalkane that is reacting with ammonia. So what actually is happening? Ammonia is acting as a nucleophile. So what happened? Ammonia, because it has got extra lone pair of electron, and here you can see the carbon has a partial positive charge, that's a partial positive dipole moment it's showing here, and bromine being more electronegative, it becomes partial negative. So because it has attracted the electrons of carbon toward itself, that's why it made itself negative, and carbon has is acting like a carbocation. So nucleophile having an extra electron, it has got more electrons. So this is going to attract ammonia as a nucleophile to donate the pair of electron to carbocation. So what happened? Once ammonia gave its electron to nitrogen, and now you can see the positive charge. This positive charge is because the nitrogen is has become electron deficient, because both the nitrogen lone pair has been utilized in this bond, right? And then what happened? This NH4 now is acting as a base. Initially it was here, it was acting as a nucleophile. That means it is going to donate the pair of electron, but here it is acting as a base. So when it is acting as a base, it will accept the H positive ion. So here this H positive ion will be taken up by the base, by ammonia base over here, and now it has become NH4 positive, and Br is from here. Here you have got one Br negative. You can see it over here as well. So now what happens? We have got an ammonium ion and bromide ion, and then we have got ethylamine as a product. So part 3 says further substitution of ethylamine molecule may occur if the halogenoalkane is in excess. State 2 features of the ethylamine molecule that make this possible. So here, because it's of 2 marks, so you have to give at least 2 points. Ethylamine has a lone pair on the nitrogen and hydrogen attached to nitrogen, which can be substituted. So basically they're talking about this ethylamine. So what happened? Ethylamine has a lone pair on nitrogen. Here it has got a lone pair. So this can carry on the reaction again and again. Further substitution of ethyl molecule may occur, right? And because the hydrogen attached to nitrogen, which can be substituted, so here it can take place again and again. Then we have this question is about the reaction of some element in group 7 when chlorine water is added to a solution of potassium bromide. We are talking about group 7 elements. A pale brown color is seen. Write an ionic equation for this reaction. State symbols are not required. So they are asking about chlorine. Chlorine water is added to a solution of potassium bromide. So here we can say when chlorine reacts with the potassium bromide, it is going to a pale brown color is seen. So you have to write the ionic equation. To obtain this ionic equation, you have to go through the whole ionic equation. Let me tell you how you're going to do it. So looking at the equation, if you are asked to write the whole equation, but here they're all be asking about the ionic equation. So if you see that potassium bromide when reacts with the chlorine, because it's in an aqueous state, it is in water. So if we split, because it is in aqueous state, we have chlorine Ka positive, Br negative, and Cl2 remains at it is, and then potassium break into its ions, 2Cl, 2Cl negative, and Br2. So basically what is happening over here, spectator ion is potassium, so we cancel out, and then we got this equation. And then they are asking chlorine is used to treat drinking water by considering oxidation number. Show that this equation represent a disproportionation reaction. So always remember, disproportionation reaction is the one in which same species is going under oxidation and reduction. So if you look at Cl2 over here, it's 0 here, and then if you see in HClO, the the oxidation number is +1. So that means when it is going from 0 to +1, it is going to be oxidized. That means it has lost one electron. And then if you look at the same species, the Cl2, 0 to it has turned into -1. So when it is going from 0 to -1, it is a reduction. That means it's a gain of electron. So that's why, how you're going to write it, you're going to say that Cl in Cl2 goes from 0 to +1 in HClO and is oxidized. So you have to write all the possible transitions. Like you have to say that Cl in Cl2 goes from 0 to +1 in HClO and is oxidized. So in this way you are going to get 1 mark. You need to explain that either it is going to be oxidized or it's going to be reduced, and from which oxidation number to which oxidation number, and in which compound are we talking about. Here we are talking about this. Okay, so and then the second point you're going to say Cl in Cl2 goes from 0 to -1. Cl in Cl2 goes from 0 to -1. So you can say Cl in Cl2 goes from 0 to -1. In HCl, here we're talking about HCl, and is reduced. So in this way you're going to get 2 marks. Then we have another question that say concentrated sulfuric acid H2SO4 react with solid potassium halide. Some observations are shown. The equation for the reaction of concentrated sulfuric acid with potassium chloride is shown. State why this is not a redox reaction. So you can see, you're going to write down the oxidation number. In sulfuric acid it is +1, and then here it is +1 as well. So there is no change in hydrogen. Same here also, the hydrogen is +1, and then sulfate is -2 over here, sulfate is -2 over here. So there is no change in oxidation number. If you look at potassium, it's +1, and here it is +1. Then we have Cl, the Cl is -1, and here it is -1. So because there is no change in the oxidation number between the reactant and the product, so it is not a redox reaction. Moving on to the next question, they say the half equation for the oxidation of iodide ion is shown. The half equation for the reduction of concentrated sulfuric acid hydrogen sulfide is shown. So we have got both the equations here. Deduce the ionic equation for the reaction between iodide ion and concentrated sulfuric acid by combining these two half equations. So you don't need to worry about because the equation of oxidation and reduction both is given, and you know when combining two half equation we get a full equation. So looking at the equation, you can see we have to balance the number of electron. Here we have 2 electrons and here we have 8 electron. In order to balance the equation, what we are going to do, we are going to multiply this whole equation by we have to multiply this by 4 because we want to make it 8 electrons, right? So in order to do that, we have multiplied over here. You can see the equation is being multiplied by 4. So we have got 8 iodide ion, 4 iodine and 8 electrons. And you know that if the same species are present on both sides of the equation, that means on the reactant side and on the product side, those are called spectator ion. And these ions are cancelled out each other's effect. So here we have cancelled out electron, and then finally we got, by adding up this side, the reactant side of all the species present on the reactant side and all the species present on the product side. So in this way we got this equation. Explain the difference in the reaction of concentrated sulfuric acid with chloride ion and with iodide ion. So we have got chloride ions and we have got the iodide ion, and you know that the chloride is as you go chloride we have fluorine, chlorine, bromine, and iodine. So basically they're talking about chloride and iodide ion. So you should know that iodide ion are better reducing agent than chloride ion, as iodide ions are bigger in size, because as we go down the group, the size of the element increases. So it's bigger in size. Outer electrons, what happen if it is bigger in size, then the outer electron is further away from the nucleus, and more shielding electrons are more easily lost from the iodide ion, because it's far away, so it can be easily lost. If it can be easily lost, that means it is going to be a better reducing agent. What is a reducing agent? Reducing agent is the one that helps other element to get reduced and itself get oxidized. Okay, moving on to the next question, that is question number 16, is an easier one. This question is about secondary alcohol. So always remember, underline the question whenever you're trying to attempt, so that you don't need to put more effort understanding the question and reading it again and again. Give a chemical test including the results to show alcohol contains an OH group, and for that, we have phosphorus pentachloride. Add this, and then misty white fumes are going to be formed. A sample of cyclohexanol contains this much carbon, this much hydrogen, and this much of oxygen. Show that this data is consistent with the empirical formula. So answer is already given. You just have to calculate the empirical formula, and then you have to match it with this answer. So everyone know how to calculate the empirical formula, or 3 elements are placed in a different columns, and the mass of carbon is given, that is 7.13 divided by its MR, relative atomic mass, and then relative atomic mass of hydrogen and oxygens is 16. So you divide it by these every element is going to be divided by its relative atomic mass, and then what we have got these value. Whichever whichever figure is the smallest, you have to divide all the other with the that number, so in that order to get a simplest ratio. So because over here we can see the smallest number is this, so we are going to divide all the rest of the 2, including this number, with this same number. So when we divide it, we get 6, 12 and 1. So that's how you got the same answer as given in the question. Cyclohexanol can be converted to cyclohexanone. So one, we have an alcohol, and then we are converting it to ketone. Name the reagent and condition for this conversion. Again, you need to learn these reagents, and you know that either it's going to be potassium dichromate, or it can be sodium dichromate, and dilutes in presence of acidic solution, that's sulfuric acid, and you have to heat this under reflux. Then we have another question, and that is related to infrared spectrum, IR spectrum of cyclohexanol. Alcohol is again here, and then describe the 2 differences other than the fingerprint region that would be expected in IR of cyclohexanone. So if it is a ketone, if it's not alcohol, because this one is given for alcohol, but what if it is of ketone, then you have to, because here you need data booklet, and from the data booklet that is provided to you during your exam, and you have to find out the value. And what you're going to say, that if it is an alcohol, then OH absorption would be absent at the wave number range of 3750. So you cannot find any absorption at this range, but because it's a ketone, so the absorption would be present at the wave number 1720 and 1720 to 1700 per centimeter. So this is how you're going to say that it's not present over here, but it is present on under this range. Give reason why cyclohexanol and cyclohexanone can be separated by fractional distillation but not by simple distillation. Obviously, because there's a boiling temperatures are too close to each other, so we cannot separate them by simple distillation. Instead, we're going to use the method that's called the fractional distillation. Then we have another question that says, discuss the reaction between sodium hydroxide and 2-chlorobutane. So we have halogenoalkane. The hydroxide ion act in two different ways depending on the reaction condition. Include the structure of 4 possible products, the reaction condition needed, and the role of hydroxide ion. So basically they're asking about if hydroxide ion is provided with 2 different conditions, what will be the product, right? And they are not asking about the detailed mechanism. They have mentioned, but in order for you to understand, I have given an explanation of whole process, how it works, because there are 2 possible conditions. Hydroxide can react in presence of aqueous, you can say the medium is given aqueous, how it is going to act, and if it is hydroxide is in alcoholic condition, then what will be the product. So it's a simple one that's also given in your book as well. So what happens if hydroxide is provided an aqueous solution, that means the medium is in aqueous. So here hydroxide will be acting as a nucleophile, and you already know that nucleophile is the one that has got extra lone pair of electrons. So in this case, in aqueous condition, the reaction is nucleophilic substitution reaction, and the product is going to be butane 2-ol, because hydroxide has acted on, always remember, the hydroxide will because it's a substitution reaction, so it will act on the positively charged carbocation, because chloride is a negatively charged here, because chloride, any halogen that is present with an alkane, halogen have more electronegativity, so it will attract the electrons toward itself, making itself negatively charged and making the carbon as a positively charged, that's a carbocation, deficient in electrons. So what happened here, hydroxide ion is going to act on this carbocation, is attracted toward the carbocation, acting as a nucleophile here. So what happened, this chloride is going to be replaced by hydroxide, so substitution is taking place, that's why it's called nucleophilic substitution reaction. Always remember, you have to place hydroxide with the carbon which was having this halogen with it, right? So here you're going to place it over here, so we have got butane 2-ol. So this is one part. What happens if hydroxide is provided with alcoholic solution? In this condition, the other type of reaction will take place, that is not nucleophilic substitution, it's an elimination reaction. So how are you going to find it out? That hydroxide over here is going to be acting as a base. What happened? It is going to act either on this hydrogen or it is going to act on this hydrogen. It is going to eliminate any of these 2 hydrogens over here. Remember, apart from the halogen is attached with the carbon, beside this carbon, the number of carbons present beside this carbon which is attached to the halogen will be the reactants, or will be the species which are going to be removed from the compound. So here what happened, hydroxide, so here we have 2 possibilities. Either hydroxide if react on this hydrogen, or it will react with this hydrogen. So once let's consider the hydroxide is reacting with this one hydrogen over here. So what happened, or you can say with a hydrogen, so the product is going to be but2ene, because here initially the hydrogen was present over here. Not only hydrogen is going to be eliminated, but Cl is also going to be eliminated. So in order for carbon to make it valency full, the valency of carbon is 4, so it has to maintain that valency. We have got one bond over here, so that's why it's called ene. That means a double bond. And what happened on the other side, if the hydroxide is reacting with B side, that means this hydrogen. So now what will happen? Obviously we have taken hydrogen from this carbon, So now the double bond will shift to this side. Now it is going to be called as but-1-ene. And then further, the reaction is not finished yet. What happened? There we have got isomers, the possibilities of isomers. Remember, isomers are formed by looking at two sides of double bond carbon. Here you can see the double bond of the carbon here, and you can see double bond carbon beside the double bond carbon, how many groups are present. So because this is a symmetric structure, so there is no isomer going to be formed on this side. But if you look at this side, what happened? The double bond carbon has got two different priority groups. So based on that, you're going to form isomers. So now we have got double bond. If the priority groups are on the same side, it is going to be called as cis. It's going to be cis, and this is going to be trans if the priority groups are on the opposite side. So this it's not Z, it's going to be E, and this is going to be Z. Always remember, E means enemy, enemies are on the opposite side. So if the priority group, how are you going to find out these are the priority group? You're going to find out the molecular mass of these two elements. So here both the priority groups are on the opposite side, so that's why it's going to be called E. And how are you going to write it? In ethyl alcoholic condition, the reaction is elimination, produce but-1-ene and but-2-ene. But-1-ene further forms the stereoisomers E but-2-ene and Z but-2-ene. Hydroxide ion act as a base. So this is how you're going to write down all these structures. Moving on to question number 17, section C. So what happened here? This reaction says, question says magnesium carbonate has been studied recently as a potential material for removal of carbon dioxide from atmosphere. The value of N in a sample of hydrated magnesium carbonate, so we have to find the value of N over here, can be determined by the reaction with hydrochloric acid. So here we have titration happening, and that's a back titration. We will find out the answer by help of a back titration. So we have got the mass of magnesium carbonate, that is 2.35. We have got the constant the moles of hydrochloric acid, that's 0.06. And what the process is happening, this is add 0.06 moles of HCl to a sample of hydrated magnesium carbonate. So basically we are putting what we are adding this much amount of moles into this much gram of sample, and then what we are going to find out what is the product that is already given in the equation, so you don't need to worry about what will be the product. Here what we are more interested in is to find out the value of N. Okay, so basically it's a back titration process. So and the titer is also given, and then they said when the reaction is complete, transfer the resulting solution to 250 centimeter cube of volumetric flask, make up to the mark with the deionized water and mix thoroughly. So then once they have added this and this, so we have got this product, right? And this product, out of this they have taken they have made the solution up to the mark, that's 250, mixed it with deionized water, and then they have taken 25 centimeter cube of this solution into a conical flask in order to titrate it, and they have titrated it with sodium hydroxide. Why? Because this solution contain HCl, right? Excess, because HCl was in excess. Here you can see it, they have mentioned that we have got HCl in excess. So whatever the solution is formed, apart from that we have got some excess HCl. In order to find out the value of that excess HCl, what you're going to do, you're going to titrate it with the help of sodium hydroxide. That's a neutralization reaction, obviously by using an indicator which is not mentioned, but we are going to use a phenolphthalein as an indicator. So and the value of the titer value is also given to us, so you don't need to do the titration calculation, that's already given to you. So now moving, because we know this value, so here we need to go back from here to here and then from here to here. That's called the back titration. So here you're going to find out the moles of sodium hydroxide in titer. So titer key, the volume of the titer is already given. The moles of NaOH in titer, by using this formula, that's concentration into volume. It and then obviously you have to divide it by 1000 in order to cancel the value from centimeter to dm cube in order to get the moles. Now we have got the moles of sodium hydroxide, and in neutralization reaction of sodium hydroxide and hydrochloric acid, the ratio is 1:1. So this number of moles will also be the number of moles of HCl, but here the moles of HCl were in this much 25 centimeter cube. So how much will be in 250, because we are going backward. So we are now, after finding the moles of HCl in this, we are moving upward to 250. So in 250 it is 0.026 moles, right? So these are the moles of HCl that are in excess, that have not been reacted. So you can say these are the unreacted one. Okay, now because we want to know the number of moles that are reacted, so in order to do that, reacted moles is equals to the total moles that were already given to us. You can see this is the total number of moles that's given to. Okay, so now we have got the moles, that's unreacted one. And in order to find out the moles of the HCl that have been reacted, what we're going to do, we are going to subtract total moles and unreacted moles. So unreacted we have already got, that is 0.026, and what is the total mole? Total mole is 0.06, that's given in the question. So once we subtract these moles, we got 0.034 moles of HCl that have been reacted. So that means now we have got the moles that have been reacted. Now what we're going to do is, because there's a lack of space, so I've continued the question over here. Once we have got the moles of HCl reacted, that is 0.034, and now you're going to compare the mole ratio, that is the mole ratio of this and this. So it's 1:2. So in order to get the moles of this species, what you're going to do, you're going to divide the moles of HCl that have been reacted with 2. So once you divide it by 2, you get this number of moles. That is the mole in a sample. And what was our sample? This was our sample. Now can you find out the number n value in this sample? Yes, of course, it's not difficult. How are you going to do it? It's very simple, but mostly the student make one mistake, that they forget to add this number. Remember, there are two different elements, compounds over here. One is magnesium carbonate and one is water, and N is with water, it's not with magnesium carbonate. So how you are going to do? You are going to place a magnesium, the relative atomic mass from the periodic table, you can find it out, that's 24, and carbon you already know it's 12, and for oxygen it is 16, but we have got 3 atoms of oxygen, so you're going to multiply it by 3, and then you have to add this with N, and then 18, the relative atomic mass of water is 18, and then by swapping these numbers you get the value N. So N is going to be the correct answer. So let's solve the other question in our next video. Thank you.